diagrams for Eclipse and the modeling framework. Maybe you already know story diagrams from Java. Java generates code from story diagrams, and we have an interpreter for that. Story diagrams are essentially human activity diagrams with these transformation nodes called story nodes. And yeah, this is a solution for the first HelloWorld case. Here we only create a node of type greeting and set its attribute to text, text to HelloWorld. And here, for these attribute assignments, you can use OCL expressions. And finally, at the final node, you can also define an OCL expression that determines the return value of the story diagram. And here, in this case, the value of the variable greeting is returned. To execute these story diagrams, we essentially the interpreter is supposed to be called from Java code, but we have a workflow framework where you can define such workflow components to execute the story diagram from the user interface. Yeah, and the result is written here to output it as my, and it's the result. Okay. Yeah, the second task is a bit more complicated, so of course you can create more complex object patterns here. The third task, here we have the import model already provided, and here the black elements form the application condition of the transformation rule, and the greeting object with the grayed out classifier label is provided as a parameter to the story diagram. Unfortunately, currently we have no way to show the user which parameters the story diagram has. Yeah, and here the story diagram interpreter searches for this pattern in the input model and creates a string result and sets the string result variable to this OCL expression. Some reviewer remarked that this syntax for string concatenation is quite complex. Well, because we use OCL, we have to stick what OCL provides. Okay, yeah, then the graph migration. Here the graph is the input model, and we create a target graph. And here we need traceability links to connect the input model elements to their corresponding output model elements. And the story diagrams don't provide a native feature for traceability links. So we have to use this helper object traceability link store. This traceability link store is has an attribute or a reference traceability links which is a hash map with a key and a value. And here the input nodes are used as keys, and the created target nodes are values in this map. And because this is not an ordinary reference, it's visualized here with this circle. Yeah, and this node has this double border, which means is executed for all matches that can be found for the application condition of the graph pattern. Yeah, and finally, our nodes have been transformed. The edges have to be transformed, and here we need the traceability links to find out which input node belongs to which output node. And between the output nodes, we create this links to reference. Okay, and the target graph is returned. One on the left, and yeah, this is the solution for the transitive edge insertion. Here we have a more complex pattern. And here, yeah, this was something we wondered about. Here we check that there is no edge between N1 and N3, and the other way around. And only in this case, if no edge is between them at all, we create a new edge. Okay. Yeah. So time is almost up. So I guess that's the field.
Great. Is there anything you want to address about the reviews, or anything like this? You mentioned the OCL automation.
Yeah, well, actually I don't remember so much from these reviews.
Sure. Okay. Did anybody review the MDELab solution and wants to make a remark? Or?
Did you solve all subparts?
Yeah, I think so. One problem was the matching of the education conditions here is isomorphic. And in some solution, I think we don't keep this in mind, so we would have to extend the solution there. But I don't remember which one.
There was only one. One solution. Yeah, we can fix it.
Okay, anything else? No? Okay. Thank you very much.